Hello and welcome to Easy as Pie with Mr. Carpenter. I am Mr. Carpenter. I'm excited for a new year and some new topics. So today we're going to hit on function notation. This is for my Algebra 1 and my Algebra 2 students. So we first learned of this thing called an expression, right, that contains these things called terms. And this expression can be whatever it wants. It really just depends on what that x is. So for example, if x happened to be 2, right, if we evaluated this for x equals 2, I'd plug in a 2. 3 times 2 is 6. 6 plus 5 is 11. That's how we start. We evaluate an expression. But there's another way of thinking of evaluating expressions in that whatever the answer was we plugged in 2, I'm going to call that the output of something called a function. So it's essentially the same idea. I have this function 3x plus 5. And its output, y, depends on what I plug in for an input, x. For example, if I plug in 2 as an input, I'm going to get 11 as an output. So this ends up becoming an input-output pair. When I plug in 2, I get 11. And that is what makes the dots on our coordinates, right? This coordinate is 2 comma 11 because when I plugged in 2, I got 11. And sometimes we have functions where the dots end up making specific shapes and patterns, but that's for a different video. To get at the point here, we can lean into this idea of a function with something called function notation. As if we don't call this y, but we instead call it a function of x or f of x, right? So 3x plus 5. So f stands for function, of course, but we don't have to use the letter f. We could use g of x or j of x, and they all mean the same thing, especially if we have more than one function and we want to differentiate between them. All it is whatever is inside the parentheses is whatever is going in as the input. So f of x is right now, it's a function of x. It depends on what goes in as the input. So if I were to look at something like f of 2, well, this is asking what would this function look like if 2 was the input? If I plugged in 2, what would I get as an output? So very simply, I would do the same thing that I do when I evaluate an expression. I would plug in 2 for x because 2 is my input. And then I would simplify, right? And that would turn into 11. So f of 2 would be 11 because when I plug in 2, I get 11. So this would, if I saw this, I could then know that the coordinate 2 comma 11 would have to be on my graph because that coordinate is simply an input-output pair. So let's erase this and look at another example. It does not have to be a linear function. In fact, any function at all. So let's do g of x. Let's go absolute value of x minus 5 over 3. And let's look at g of 14. So if it's g of 14, I want to know, well, if I plug in 14 as an input, what would the output be? So, and I see that x, I'm going to plug in a 14. And then I go and I simplify, right? 14 minus 5 is a 9. Absolute value of 9 is 9. 9 over 3 is 3. So g of 14 is 3 because when I plugged in 14, I got 3. And I know that coordinate has to be on the graph of this function. Now, when you move forward in algebra, you learn that you don't necessarily have to plug in a number for this function notation, and that's what makes it so versatile. For example, I could go g of x plus 2, right? And you might look and be like, well, what just happened here? The same thing is happening. If I plugged in x plus 2 as an input, what would I get as an output? And what I get as an output is going to have a variable in it because I can't really do much with the x, but I can still simplify it. So absolute value of, I see that x, I'm going to plug in an x plus 2. So in parentheses, minus 5 over 3. It's the same thing if I plugged in something like 9 or 14 or whatever. Instead, now it's its own expression. And then, so 2 minus 5 is -3. And that would be g of x plus 2. It's a different way of thinking of this function. The last thing that I want to talk about is a question that could be worded this way. F of x equals 2x minus 10, let's say. And it'll say, for what value of x is f of x equal to, let's say, 20. For what value of x is f of x equal to 20? And this can be tough to look at if you don't understand the notation. So we have this function, and this function is going to be equal to 20, depending on what input I plug in. So the question is, what can I plug in for an input that would result in this simplifying to the number 20? And I can guess and check for sure. I can, test out f of 4. Maybe it's f of 4. 2 times 4 minus 10. That's 8 minus 10. It's -2. That's not 20. So it's not that guy. But we don't have to guess and check because we can solve an equation, right? And the equation is laid out for us right here. F of x, well, that's 2x minus 10. So this function is equal to 20. And what input do I have to plug in for this to happen? And then I use my equation solving techniques. I'm going to do the opposite of subtracting 10. And then I'm going to do the opposite of multiplying by 2, which is division. And I get 15. And let's go back and look at this. The answer is 15 because f of 15, I plug in 15 for x. So 2 times 15 minus 10, that's 30 minus 10, that is 20. So when I plugged in 15, I got 20 as an output. So that's the value of x that will allow this to happen. And that is all for function notation. Thanks for watching. We'll see you in the next video.